Hi everyone, this is a video about reciprocal functions, that is functions related to y equals 1 on x. So we're going to look at what the parent function looks like, and look at some key features, asymptotes and intercepts, and we're going to look at transformations. Okay, now just to get a better understanding of what this looks like, y equals 1 on x, we could do a table of values and plot the points like I've done here. But what happens when you do x equals 0? You get 1 divided by 0, which is undefined. So Excel couldn't deal with it. So when I graphed it on Excel, it went through there. If I added a few more points in between -1 and 1 here, I get a bit more detail, but still I can't deal with this point here. So basically what we see happening is the bigger the number for x, or the bigger the absolute value of the number, the smaller the number for y, absolute value, because it's a fraction, right? So 10 becomes 1/10. X equals 9, so y is 1/9. Okay, so as it goes on, and then the smaller the number gets, the x value gets, the bigger the y value gets in terms of absolute value. So it will be very close to the x-axis, and then as you get closer and closer to the y-axis, it gets bigger and bigger in absolute value terms, so it is approaching 0. What happens when it gets to 0 exactly? It's undefined. So if we plot this on a graphing program, it looks like that. Okay, so some key features you need to know about this graph y equals 1 on x is that when we zoom out, you can see as well, it gets closer and closer to the x-axis and closer to the y-axis. It's almost merged with that. And so the key features we want to say is it's called a hyperbola. That's the shape of it. We can have all real numbers for x except for 0, because 1 on 0 is undefined. Now if we rearrange this equation for x, 1 on y, you can have all real numbers except 0 again. So what does that mean? As it gets closer and closer to 0, it will go closer and closer to this y-axis, but never cross it. So that we call that an asymptote. Asymptote, so A is it's not, and sim, like symphony, is together, so it's not going to be together with that line. So they're never going to meet. It's going to get closer and closer, but never cross. So there's going to be no intercepts. It's going to get closer and closer to the x-axis here, but never cross. Closer and closer to the x-axis here, never cross. Closer and closer to the y-axis here and here, but never cross. So that's the key features of y equals 1 on x. In the next few minutes, I'll show you some related functions and see how they have very similar features. Okay, so now I'm using the graphing program Desmos to illustrate what happens with reciprocal functions. So we're going to start with our parent function, our initial function y equals 1 on x, and see what happens when we change it to y equals a over x minus h plus k. Okay, so what do each of these values here do to our function? So right now I've got a equals 1 and h and k equals 0. Let's start by moving h around. So as I change h, you can see that it moves the function either left or right. So if I have 1 on x plus 4, and so minus 4, 1 on x plus 4, it looks like that. If I have 1 on x minus 4, it will look like that. Okay, what specifically does that mean? It means, again, no x-intercept, but the vertical asymptote will now be at x equals 4. let me make that dotted. X equals 4. Okay. So the vertical asymptote will be whatever h is. Okay, let's change k. So again, that's moving it up and down. And if I just quickly highlight this, the horizontal asymptote will be whatever k is. So there is y equals 1 on x minus 5. There's y equals 1 on x plus 3. And there's your horizontal asymptote. So if we have y equals 1 on x minus 4 plus 3, that's going to be that will be what it looks like. It's going to be moved 4 to the right and 3 up. Okay, let's bring these back to 0 and have a look at what happens with A. So as A gets bigger, the lines get further apart. Okay, as A gets smaller, lines get closer and closer to the x and y axes. Okay, so yeah, as it gets bigger, they get further apart. As it's smaller, it gets closer and closer. There's still no intercepts, and the asymptotes are still the x and y axis, or x equals h, y equals k. If it's negative, just like quadratics and all the other functions you've probably heard about, it's a reflection in the x-axis. So instead of being in the first and third quadrants, it's in the second and fourth quadrant. Okay, again, bigger it is, the wider apart it is. The smaller it is, the closer to the axes it becomes. Okay, so negative is just the positive one flipped over. So now if they ask you to draw y equals negative 4 over x plus 3 plus 4, okay, plus 3.8, 4, there you go. That's all you'll have to do. Okay, put in your x and y asymptotes and then draw it through. Okay, if you want to know where it crosses the x-axis, put y equals 0 and solve it. If you want to know where it crosses the y-axis, put x equals 0 and solve it. Okay, and you get those extra points there. There are some other tricks you can do, and I think you should just investigate yourself. Like, you can draw a 45-degree line there through the they're not turning points, but the points closest to the focal points, closest to the intersection there. So explore a bit more. Get on Desmos yourself. This is a great program, and you can see what happens when you manipulate these things. You can even animate it, okay, and see what happens when you're changing all these numbers, and you'll learn a lot about what's going on with these reciprocal functions. All right, hope that's helpful. Good luck.